Assalamu alaikum. Welcome to Turkish Engineering. We have a nitrous oxide decomposition reaction here, and it has a specific reaction rate which is like different than what we saw at the previous videos. We have only like first order, second order rate, okay, which is like we were talking about something like this, right? Ca. It can be like the power can be 1, 2, first order, second order, but sometimes you have like fractional expression. You have a reaction concentration term in the numerator and also in denominator. So how do we solve this kind of problems? We will have two regimes. We cannot decide the rate of reaction. We should look at the denominator and compare the values. Let's say I start by high concentration of, like at the beginning I have high concentration of nitrous oxide. So I will have this term, or we can also express like this, okay? You can express like this as concentration of nitrous oxide, or you can also write like this. But when you see this parenthesis, always it's like concentration. We are talking about concentration. Okay, so this term actually at the beginning, when this is too high, we'll end up with concentration is too high, so it will be like this, and we can neglect 1. Why? Because 1 is relatively too small than K2 times. So it depends also on the reaction rate, and not like this coefficient, reaction coefficient. Not only the concentration. Compare it, like when we compare them, it's 1 is too small than the other term, so we can neglect, and we say the rate of reaction of nitrous oxide will end up with over K2 N2O. So this term will cancel the square, so it will be K1 over K2, which is the final coefficient of this regime. So you have N2O, which is first order, okay? So it is first order because the power of concentration is 1. And in the second regime, when you have this term is like almost equal to 1. Why? Because you have 1 is like relatively too bigger than K2 times concentration term. So you can neglect this term and say, now my reaction rate is something like this, square over just 1, okay? So you see that we have 2 as a power of concentration, so it will be here second order reaction. So we cannot decide the rate of reaction at the beginning. We should look at the denominator and divide it into 2 different regimes depending on the relatively comparison of the constants and the concentration terms. Then we divide into 2 or maybe sometimes more than 2 regimes. That's all, and thank you for watching.